Okay, let's do a circuits problem. This is one that I made up for a previous class. Note, the diagram looks really pretty because I did this I don't have the address, but if you Google FET, there's a circuit simulator and you can build this and you can actually measure the current. It's pretty cool. And then I just printed it out. Okay, so I have these two batteries and I have two resistors, but I have it in this stranger connection here. And the question is, what's the power dissipated in each of the resistors? I'm going to show you how to calculate power, but the first thing we need to do is find all the currents. So we have three branches, so we have three currents. So let's just call this one I1. This one's a positive battery. Let's call this one I2. And let's call this one going that way I3. And I'll call that resistor 1 because it's with current 1. And I'll call this resistor 2 even though that it has a value 2. And that's the EMF 1 and EMF 2. I'll leave them at 0. Okay, so now we can use our two rules. We have the junction rule and the loop rule. I'm going to need at least 3 equations, maybe. I actually don't need 3, but to solve this whole problem. So I could do 2 loops and 1 junction. Let's just write down the junction rule, even though it might not be super needed right here. So let's look at this junction. I have current I1 and, oh, that should be I wasn't thinking, I2, I3. Okay, so I have current I1 plus I3 coming in, and then I have I2 going out. So those have to be equal. So that's one equation. I don't know I1, I2, or I3, but it's an equation that relates them. Now I need to do a loop. There are actually 3 loops you can do. I need to do 2. Here I could do this loop. Let's just do this in red. I could go from here. That's a loop. I could do this loop. And then I could do this loop. Yeah. So I'm going to write down all 3 loops, okay? And I'll show you the ones that are the best, which you wouldn't have to do. So I'm going to start right here, and I'm going to go around this loop. So first I get 1.5 volts, and then I have I1, and then I go down here. I have I2 going in the same direction as I2, so it's going to be minus I2 R2. That's the voltage drop across that resistor. And then I come up here. Again, I'm going in the same direction as I1, so it's going to be minus I1 R1. And then I get back to the same point. I get to 0. So in this equation, I don't know I2 or I1. Okay, now the next loop, let's do this big loop right here, going all the way around here. So again, I'll start right there. I'll get 1.5 volts. And then I come down here. And then I go from this point to that point. Remember, this is the plus side and that's the minus side. So since I'm going from positive to negative, it's final minus initial, so I'm going to get a negative 3 volts. Now I'll come back up here. Now I'm going again with the current, so I get minus I1 R1 equals 0. Maybe you can see that's a pretty good equation. I'm going to put a box around it. Boxes go around good things. Okay, and then I'm going to do this last loop right here. Let's start right here and go around this way. So I'm going to get plus 3 volts. Now I'm going with the current, so I get minus I2 R2 equals 0. Notice that I3 doesn't even come in any of these 3 equations because it doesn't pass through a resistor. I don't have a resistor in this branch, which is okay. But that's also a good, I put volts. Well, it is 3 volts. That's another good one. So both of these are great equations because I only have one variable here. I only have one variable there. Isn't that nice? Okay, so let's solve this one for I1. You could do it this one too. You will get the same answer. Okay, I just have a little bit of experience here, so I know what works best. But don't be intimidated. Don't worry about doing things the wrong way or the more difficult way. That's how you learn. I've only been doing physics for 25 years. It's not a big deal. Okay, so this one I can solve for I1. So this is going to be negative 1.5 volts when I combine those two together. So I get negative 1.5 minus I1 R1 equals 0. So I1 is going to be negative 1.5 divided by R1, which is 20. Is that right? I feel like I made a mistake. I redid this problem to, I think this is right. But I think I might have made a mistake in my calculation. But if I did, I'll fix that. Okay, so that's the current I1. Now down here, I can do I2. So 3 equals I2 times R2, which is 10. So I2 is going to be equal to 3/10 amps. This is amps. And what does this negative sign mean? This just means that the current, I picked the current the wrong way. Okay, so I said the current was coming this way out of the positive end of the battery, but it's actually not. Because of this battery right here, it actually has current going into the battery. So it's like it'd be you're charging the battery or something. I mean, normally that's a bad situation, you don't want it. But I just made this up, so that's fine. Okay, so there I have my two currents. Now I can find the power. So let's talk about power. Let's say I have over here, I have a resistor. And then in this resistor, I have a current, and that has a resistance R. So if I imagine there is some change in potential across that resistor, delta V, if I take some amount of charge delta Q and I let it go across there, then I can find the change in energy is going to be delta Q delta V. Remember, we define the electric potential as the change in potential energy per charge. So if I just go backwards the other way, I can find the change in potential energy. Now, power is defined as the change in energy, the rate of change of energy. So if I use my change in potential as my energy, and I divide by time, I get delta Q, delta V over delta T. Now, delta Q over delta T is I. Not I, me, it's the current. Remember, we define current as the rate of change of charge flow. So this part right here is the current. So I get I delta V. Delta V is the power. Now, what if I don't know the potential? Well, Ohm's law says delta V is IR. So if I put this in right here, I get power equals I times IR, which is I squared R. Yeah, that's right. I did that right. Okay. So now I can calculate P1. It's just going to be I1 squared R1. Now, I think, and it doesn't matter the direction of the current because you're squaring it. I think I did this, but I feel like it might be wrong. I put in my values, and I got 0.1125 watts. And then P2 is going to be I2 squared R2, and I got 0.9 watts. And if that's wrong, I'll put a comment below with the correct answers. But I just put that in my calculator. And I feel like I got a different value for my current, but I'm pretty comfortable with that. Also, if you go back over here, the other thing that's nice, you can actually, like I said, set this up in the simulator and just measure the currents, and that'd be kind of fun too. All right, physics people, let's do another one later.